first question here, problem number 12.1, is prove that 1 minus cos 2 theta by sin 2 theta is equal to tan theta. Now, this is a problem that you will come across very frequently later on also. Okay. So, left hand side is 1 minus cos 2 theta by sin 2 theta. Now, if you see 1 minus cos 2 theta from the multiple angle formula is 2 sin square theta. And the multiple angle formula for sin 2 theta is 2 sin theta cos theta. Okay, so the 2's cancel and 1 sin theta cancels from the numerator. So only left with sin theta by cos theta. Which is equal to tan theta, which is equal to right hand side. So this was a 2-line problem. So a 2-line problem, but as I told you, a very important problem. Well, let's proceed with the second one. The next question here is prove that 1 plus sin 2x plus cos 2x by cos x plus sin x is equal to 2 cos x. So we start from the left hand side. 1 plus sin 2x plus cos 2x divided by cos x plus sin x. Now in the numerator, if you see, you have multiple angles 2x. So you have sin 2x and cos 2x. Convert all of them to sin x and cos x. Okay. So in order to convert this to sin x and cos x, you take these two together, 1 plus sin 2x. Okay. Now this one, again, this is also a very important problem. You will also come across this problem very frequently later on. Okay, 1 plus sin 2x. This is something that is very, very important. 1 you can write as cos square x plus sin square x. Right? And sin 2x you can write as 2 sin x cos x. Okay. And cos 2x, the multiple angle formula for cos 2x is cos square x minus sin square x. In fact, there are other forms also, like 1 minus 2 sin square x and 2 cos square x minus 1. But we'll use cos square x minus sin square x. Why should we use cos square x minus sin square x? Because if you see the first part, cos square x plus sin square x plus 2 sin x cos x, this becomes cos x plus sin x whole square. And cos square x minus sin square x can be factorized as cos x plus sin x into cos x minus sin x. And the denominator you keep as it is. So now if you see cos square x plus sin square x plus 2 sin x cos x, as I told you, will become cos x plus sin x whole square. So what you see here is that this part, 1 plus sin 2x, has been written as cos x plus sin x whole square. This is very important. Okay, remember this step. Plus, now if you see cos square x minus sin square x, this part can be factorized as cos x plus sin x into cos x minus sin x. And the denominator you keep as it is, because the denominator is going to cancel later on. So now cos x plus sin x you can take common. If cos x plus sin x you can take common, then what are you left with? You are left with cos x plus sin x And you are left here with cos x minus sin x. And in the denominator, you have cos x plus sin x. That means this and this now will cancel. Once they cancel, now the remaining part, what you see is that here plus sin x and minus sin x are going to cancel. So what are you left with? You are only left with cos x plus cos x, which is equal to 2 cos x, which is equal to RHS. Okay, another very important problem. Any question? Both of these were very important problems. We start with 12.3. This is very similar to 12.2. You have left hand side as 1 minus cos 2x plus sin x divided by sin 2x plus cos x. Now out here, if you see, you have multiple angles in the numerator as cos 2x, and in the denominator the multiple angle is sin 2x. You convert all these multiple angles to uh, normal angles. So 1 minus cos 2x going to formula is 2 sin square x, and plus sin x you write as it is. Sin 2x now can be written as 2 sin x cos x, and this cos x you write as it is. Now 2 sin x, in fact sin x you can take common in the numerator. So you are left with 2 sin x plus 1. And in the denominator, you can take cos x common. You are left with 2 sin x plus 1. So you see that 2 sin x plus 1 cancel in the numerator and the denominator. You are only left with sin x by cos x, which is equal to tan x, which is equal to RHS. Another very important problem. Okay, you take note of these problems. We shall be using these very, very frequently in the times to come.
Okay, sir.
12 part 4. You need to show here that cos theta by 2 plus sin theta by 2 whole square is equal to 1 plus sin theta. Now this is just the converse of this problem that we have done. We had shown this part is equal to cos square x plus cos x plus sin x whole square. That is just the converse of this. So you have cos theta by 2 plus sin theta by 2 whole square is equal to, expand this by a plus b whole square formula. So you have cos square theta by 2 plus sin square theta by 2 plus 2 sin theta by 2 cos theta by 2. Now cos square theta by 2 plus sin square theta by 2 is 1, and 2 sin theta by 2 cos theta by 2 by submultiple angle formula is sin. Let me write this as twice theta by 2, sin 2 theta, right? So this will become 1 plus sin theta. Okay. Alternatively, you could have done this also from the right hand side by starting from the right hand side. If you see RHS, why I'm showing you this is because again you will need this 1 plus sin theta. See, this 1 here can be written as cos square theta by 2 plus sin square theta by 2. And this sin theta can be split with the help of multiple angle formula as 2 sin theta by 2 cos theta by 2. Now if you see, this is a square plus b square plus 2ab form, which can now be written as a plus b whole square, which is equal to LHS. Okay, so both ways it will work, and both ways you should remember the proof of this. You'll be requiring this later on. Part 5. Left hand side is equal to sine 2a by 1 minus cos 2a. Again, this is very similar to this problem, 12 part 1. So you have multiple angle formula in the numerator in the form of sine 2a. So you write this as 2 sine a cos a. And denominator, the formula for 1 minus cos 2a is 2 sine square a by 2. So this 2 and this 2 will cancel. One sign will cancel in the numerator. Sorry, this is 2 sine a by 2 cos a by 2. This isn't, sorry, no, this is not 2 sine square a by 2. In fact, this is 2 sine square a only. Because you have a 2a angle here. So 2 sine square half of 2a, which is sine square a. So 2 will cancel and one sign will cancel from the numerator. So you only left with cos a by sine a, which is equal to cot a, which is equal to RHS. Okay. Number 6. Start from the left hand side. We have sine theta plus sine 2 theta divided by 1 plus cos theta plus cos 2 theta. First of all, convert all the multiple angles to your normal angles. So you keep sine theta as it is, and sine 2 theta you write as 2 sine theta cos theta. And 1 plus cos theta, again you write as it is. And cos 2 theta, what are the form for cos 2a? Cos square a minus sine square a. Another form is 2 cos square a minus 1. Another form is 1 minus 2 sine square a. So cos 2 theta you write as 2 cos square a theta minus 1. Why do you write as 2 cos square theta minus 1? So that this plus 1 and this minus 1 gets cancelled. So now from the numerator, what can you take common? From the numerator, you can take sine theta common to get 1 plus 2 cos theta. And in the denominator, you can take cos theta common to get 1 plus 2 cos theta. So now you see that 1 plus 2 cos theta, they cancel. You only get sine theta by cos theta, which is equal to tan theta, which is equal to your right hand side. And that is proved. Okay. Next is number 7. Now 7 is a very interesting problem. You have to prove that 2 cos a is equal to square root of 2 plus square root of twice 1 plus cos 4a, where a is in the first or the fourth quadrant. What does it mean? First or fourth quadrant means cos has to be positive in both the quadrants, right? In the first quadrant, cos is positive. Also in the fourth quadrant, cos is positive. That is what they mean by saying that a is in the first or fourth quadrant. So we start from the right hand side. Square root of 2 plus 2 plus square root is there. Twice 1 plus cos 4a. Now if you see, you write this 2 plus as it is, and here within the second radical, you have twice, you have 1 plus cos 4a, right? Now 1 plus cos 4a according to multiple angle formula is 2 cos square half of 4a. What is half of 4a? It's 2a, right? Next, square root of 2 plus square root. Now 2 into 2 cos square 2a will become 4 cos square 2a. So this becomes square root of 2 plus 4 cos, square root of 4 cos square 2a is nothing but 2 cos 2a. Now, within the radical, you take 2 common. You are left with only 1 plus cos 2a. So you get square root of twice. Now 1 plus cos 2a again by multiple angle formula is 2 cos square half of 2a, which is 2 cos square a, which is equal to square root of 4 cos square a. And square root of 4 cos square a is 2 cos a, which is equal to your left hand side. And hence that is proof. Any question here?
No, sir.
Let's proceed to the next one then. Part 8. The question here is prove that sine to the power of pi by 8 plus sine to the power of 3 pi by 8 plus sine to the power of 5 pi by 8 plus sine to the power of 7 pi by 8 is equal to 3 by 2. You start from the left hand side. Sine to the power of pi by 8 plus sine to the power of 3 pi by 8 plus sine to the power of 5 pi by 8 plus sine to the power of 7 pi by 8. The first two signs you write as it is, because the third and the fourth signs that you see, that is sine to the power of 5 pi by 8 and sine to the power of 7 pi by 8, can be expressed in terms of the first two signs. So that is why we are writing the first two signs as they are. Okay. So sine to the power of 5 pi by 8 can now be written as sine to the power of 8 pi minus 3 pi by 8 plus sine to the power of 7 pi by 8 can be written as 8 pi minus pi by 8. So sine to the power of 4 pi by 8 plus sine to the power of 4 3 pi by 8. Now if you separate here in the third sign, what do you get? You get pi minus 3 pi by 8. Check the step if it is clear. And the fourth sign you can write as pi minus pi by 8. Any question in this step?
No, sir.
So sine to the power of pi by 8 plus sine to the power of 4 3 pi by 8 plus sine to the power of 4. Now you have pi. Write it as an even multiple in terms of twice pi by 2 minus 3 pi by 8 plus sine to the power of 4. You write this as 2 into pi by 2 minus pi by 8. Sine to the power of 4 pi by 8 plus sine to the power of 4 3 pi by 8 plus, now you see this is an even multiple of pi by 2. So sine will remain sine and the power is even. So even if it becomes negative, it becomes positive. Okay, twice pi by 2 minus 3 pi by 8. This is in the second quadrant. So this is positive, becomes 3 pi by 8. Plus, and here also if you see, this is an even multiple of pi by 2. Sine remains sine. And because this is an even power, so no problem. Till now we don't know whether it is negative or positive, but now we look at the angle. We see that the angle is in the second quadrant where sine is positive, so no problem, it is positive. So this is sine to the power of pi by 8. So now you see sine to the power of 4 pi by 8 plus sine to the power of 4 pi by 8 will give you 2 sine to the power of 4 pi by 8. And here you will get 2 sine to the power of 4 3 pi by 8. So that now from these two I can take 2 common. Twice sine to the power of 4 pi by 8 plus, do you see any distortions in writing? Yes, any distortion you
No,
can see in
sir.
the writing? Writing is okay.
No, sir.
Okay. So
Yes,
sine
sir.
to the power of 4, 3 pi by 8. Now you see that sine to the power of 4 pi by 8 can be written as sine square pi by 8 square plus sine square 3 pi by 8 whole square. Okay. Now this is a square plus b square. And you know that a square plus b square is a plus b whole square minus 2ab, right? So you write this as twice sine square. Now even before that, I think this 3 pi by 8 can be changed. Okay, so let's change this before doing this step. Even before this step, let's change this. 3 pi by 8 can also be expressed in terms of pi by 8. So you have twice sine to the power of 4 pi by 8 plus sine to the power of 4. Now 3 pi by 8 can be written as pi by 2 plus pi by 8, right? And you can write pi by 2 as 1 into pi by 2. So now this becomes sine to the power of 4 pi by 8 plus, now you see that this is an even multiple, odd multiple in fact, 1 into pi by 2. The sign will change to cos. And which quadrant is this angle in? This is in the second quadrant. So it will become, it will be positive. Besides, we also have a power 4. So we should not worry about the negative sign because the even power will make the negative sign positive. So this becomes cos to the power of 4 pi by 8. So now both the angles we have changed to pi by 8. Now we are in a position to write this as sine square pi by 8 square plus cos square pi by 8 square. Now we note this formula of a square plus b square is equal to a plus b whole square minus 2a. So you can apply this formula here to write this as twice sine square pi by 8 plus cos square pi by 8 plus 2 sine, sorry, this is whole square, a plus b whole square minus 2ab. So 2 sine pi by 8 cos pi by 8. Okay, now sine square pi by 8 plus cos square pi by 8 is simply 1. So this becomes 1 square, which is simply 1. Now minus 2 sine pi by 8 cos pi by 8. This part here is a multiple angle formula. Sine 2 theta is equal to 2 sine theta cos theta. So this becomes sine of twice pi by 8. Right? So this becomes 1 minus sine pi by 4. Okay, and sine pi by 4, you know, is this is okay. I have forgotten the square here. This a was a square, right? And b was a was sine square pi by 8, b was cos square pi by 8. So this should be a square here also. So before I write it as a multiple angle formula, you can write this as 1 minus um, this is 4ab, no? A plus b whole square minus 4ab. So this should be 4. Yes. Now it's okay. So now you can write this as 2 sine pi by 8 cos pi by 8 whole square. Okay, so now this can be written as 1 minus 2 sine pi by 8 cos pi by 8 by multiple angle formula. You can write as twice pi by 8 and with a square obviously. So what you get here is twice 1 minus sine square pi by 4. And you know the value of sine pi by 4, right? What is the value of sine pi by 4? Sine 45, 1 by root 2. So this is twice of 1 minus half, which is 2 into half. 2 into okay, if I have taken 2 common here, um, twice of okay, this should be 2 only. Why have I made it 4? I was correct initially. You don't know the formula for a square plus b square? A square plus b square is a plus b whole square minus 2ab. I was correct here. So this should be twice of this. Okay, so now when I'm taking a square here, that means because I'm inserting a square here, I will have to, or what you can do is you can take this 2 out. And write it as sine pi by 8 cos pi by 8, right? Whole square. Now what you can do is you can multiply throughout by 2. Yes, Sujal, you have any question?
No, sir.
So this is twice 1 minus, you can multiply this by 2 throughout. So you get 2 minus 4 sine pi by 8 cos pi by 8 square. So this becomes, now if you take this 4 inside, this becomes 2 sine pi by 8 cos pi by 8 whole square. So this becomes 2 minus sine twice sine 2 theta square. So now this becomes 2 minus sine square pi by 4. So this becomes 2 minus 1 by root 2 square. Becomes 2 minus half. Which if now if you take the LCM, you will get 3 by 2. And that is your right hand side. Okay. So now no one corrected me here. You don't know the formula for a square plus b square? Yes, Piyush?
Yes, sir.
You did not correct me also. Anyway, moving on to the next problem. Number 9. Left hand side. You have to show that 1 by sine 10 degree minus root 3 by cos 10 degree. You have to show this is equal to 4. Okay. So what you do in such a case, you take the LCM first. The LCM will be sine 10 degree cos 10 degree. Okay. So what are you left with in the numerator? You are left with cos 10 degree minus root 3 sine 10 degree. Yes. Now you apply that technique which I told you when I was doing compound angle. If you remember, I told you this is a very important technique. What you do is you take 2 common, you get half cos 10 degree, and here you get root 3 by 2 sine 10 degree divided by, and here you can also write um, you can write sine 10 cos 10 here, as it is. We can adjust this a little later. Now first let us take care of the numerator. In the numerator now, if you see, half can be written as sine 30. Cos 10 degree we write as it is, minus root 3 by 2 can be written as cos 30 degree. In sine 10 degree we write as it is. And the denominator you have sine 10 degree cos 10 degree. So what is the numerator here? What compound angle formula? Anyone?
Yes, sir.
What compound angle formula is it in the numerator?
Sir, it is sine 30 minus 10 degree.
Yes, sine A minus B formula. Sine A cos B minus cos A sine B. So this is sine A minus B. A here is 30 degree. B here is 10 degree. Divided by sine 10 degree cos 10 degree. So what do you get here? 2 sine 20 degree divided by sine 10 degree cos 10 degree. And now sine 20, what can you write it as? If you want to express this as a multiple of 2, you can write this as 2 into 10 degree divided by sine 10 degree cos 10 degree. And the numerator you have sine 2 theta, which can now be written as 2 sine 10 degree. 2 is already here, so you in fact get product of 2 and 2. So 2 is already here. Sine 2 theta can now be written as 2 sine theta 10 degree cos theta 10 degree divided by sine 10 degree cos 10 degree. Okay, so what are you left with here? Sine 10 cancel, cos 10 cancel. You get 4, which is equal to your right hand side. And that is what you had to prove. Okay, so I'll stop here.